Yes, my dear student, welcome you all. And in this video, I am going to solve the problem on the spring structure, spring problem. So here, three springs are connected in a series. The spring stiffness is given for K1, it is given as 10, and for K2, given as 15, and for K3, given as 20 pounds per inch. And the load, that is phi lb, which is acting at node 3. In the diagram it is not mentioned, but when I checked, I found the load is acting at node 3 with a value of 5 pounds. Okay, so now you need to determine the deflection at node 2 and node 3. Okay, so there will be deflection at node 2 and node 3 because the node 1 and node 4 are fixed. Okay, these two are fixed. It means there will be zero deflection at node 1 and node 4. Right, the value of k1, k2, k3 which is already clear, and load is acting at node 3, that is towards right side. Okay, so now let us solve this problem by using the finite element method. As you know that for a spring element or the bar element, the stiffness matrix will be where k is equal to, it is stiffness value of small k, in the bracket there will be 1 minus 1 minus 1 1. Okay, if it is a bar, the value of k we have taken as ae by l. Okay, but in this question the value of stiffness is directly given, so now you have to just substitute the value of k for this is element 1, say this is element 1. Now from here to here 1 to 2, and here 2 to 3 the element 2, and 3 to 4 is the element 3. Okay, so there are 3 elements and 4 nodes. Okay, and number of degree will be 4 only. Number of degrees, degree of freedom, for this it will be 4. Right, so now first let us calculate one by one the stiffness matrix for each element. So each element means there are 3 elements, so connected from 1 to 2, 2 to 3, 3 to 4. Okay, you have to remember how it is the connectivity table. Okay, so as per your diagram it will be changes. Now for element 1, okay, element 1 means you can make suffix 1 or super suffix 1, say k1. K1 is equal to the value of k, that is given as 10, and in the matrix there will be 1 minus 1 minus 1 1. Right, so you can take inside the matrix as 10 minus 10 minus 10 10. Right, so now at the outside the matrix you have to write the deformation. Okay, what are the deformation are using here? It means how it is connected for element 1. Element 1 is connected for 1 to 2, 1 to 2. Okay, as I already explained, it is connected, this element is totally connected with a line of 192. So say this is equation number 1. Similarly, we'll calculate for equation number 2 also. Okay, for 2 the value is 15, same you can write as 15 minus 15 minus 15 plus 15. And now important thing is the deformation. What will be the deformation will be here. Okay, so now 1 to 2 is connected for element 2, it will be 2 to 3, connected for 2 to 3. Say this is equation number 2. Now for element 3 the value is given for stiffness is 20, so again the matrix will be 20 minus 20, so minus 20 plus 20. So what are the deformation here? 1 to 2 is connected, now 2 to 3, here 3 to 4. Okay, this is very important to write the deformation or displacement, as you can see. Okay, so after making all this element stiffness matrix, you have to go for next, that is global stiffness matrix. Okay, global stiffness matrix. So in many of the video I explain about global stiffness matrix, and I've made a separate video on this also. You can just check out in the my playlist. Okay, FEM playlist. Here you have to make the number of nodes are, okay, the nodes are 1 to 4. Say this is the node 1, node 2, and node 3, node 4. Similarly, 1, 2, 3, 4. Only few I will explain here, remaining you can calculate. Now 1, 1. So this is 1, 1 represent, it is first row, this is first column. So what should be here at this point? So 1, 1, in all the three metrics you have to check. Where is the 1, 1? So here, first row, first column, here you got 10, and here there is no 1, 1, here also no 1, 1 in the equation 3 also. So it is 10. So you can directly write as this value as 10. So here you can write as 10. Now 1, 2. 1, 2 also you can get in the equation number 1 only. 1, 2 minus 10. Okay. So this is minus 10. Now 1, 3. In all the three equations, there is no 1, 3 connection. So it will be 0, 1, 4 will be 0. Like that, you have to calculate for all these values. Okay. So that has been done here in this same thing. Okay. As I have written the first row, 10 minus 10, 0, 0. Okay. So the bracket should be here. Okay. Like that. It is shifted just. Okay. This is matrix and these are the deformation 1, 2, 3, 4. Like I have written outside. So finally, you got this. Okay, 10 minus 10 0 0 minus 10 25 minus 15 0 0 minus 15 35 20 minus 20 0 0 minus 20 20. So say this is equation number 4. So this matrix we call as global stiffness matrix, that is equal to k. K is nothing but indirectly you can say k1 plus k2 plus k3. Finally you got the k value. Okay, this is k value. So k value will be here now. So you have to write in the finite element equation, that is F is equal to K into U. Okay. So this is a force equation. What are the force at each node? There will be 4 force. This is F1, F2, F3, F4. It should be in the matrix. So actually it should be here. Now is equal to, again, same K value. The same equation number 4 is here. And this is the displacement vector. How many displacement will be? At each node there will be each displacements. Okay, each deformation. So there are 4 nodes, there will be 4 displacement, and 4 nodes there will be 4 forces. So after that you have to apply the boundary condition. This is very important to understand the boundary condition, because here, as already I said, 1 and 4 are fixed, so there the displacement u1 and u4 will be 0, right? So these two are taken here, and force is applied. Where it is applied? At node 3. How much is the value? Let us see what will be the value is given for force. It is here 3, but I think in question some other value is given, so you have to check it. Okay, before proceeding applying, sir, yeah, I am right. So the p value is given 5 lb here, and here it is taken as something 3 lb. Okay, so you can check there is an mistake in this. So value should be 5 as per the question, and here it is taken 3 and substituted 3 only, so definitely you are getting different answer. Okay, so mistake is there, just know the procedure how to solve, that's it. Okay, so once the boundary condition is applied here, so there will be next elimination method. So how will be apply the boundary condition? For example, u1 u4 is 0 and u2 u3 you have to remains unknown. Okay, now after that here this row, entire this row and their column, means first row first column, this column will be eliminated. Now last row and the last column will be eliminated. What will be the remaining? Only this matrix. Okay, that only we have written. There will be force F2 and F3. Okay, So F2 there will be no force, so taken as 0. There is a F3, that is you can take as 5 or you can take as 3. Okay, if you take in 3, then this will be force vector is equal to matrix 20 minus 15 minus 15 35 is into the displacement will be u2 u3. Now you will get a two unknown equation like this. So 20 u2 minus 15 u3 is equal to 0. Second one, minus 15 u2 plus 35 u3 is equal to how much? It is 3. Now you have the two unknowns. Using the calculator or using manually, you can just make the equation here, then you will get the u2 u3 value. Okay, so it should be in inch because the units are given in inch. Okay, so in this way you can solve the any spring problems, even they are arranged regularly in series or parallelly, or even though if they are arranged in a randomly also. Okay, same method you have to apply to solve this problem. And thank you for watching.